Hi, this is Chris Wingard, Senior Faculty Research Assistant and the OOI Endurance Array Data Lead. In part 2 of the presentation, I will address the fixed time series DO measurements, specifically sensor locations and sampling frequencies, data quality issues and assessment procedures, data access, available data products, and briefly highlight a regional scale event we've been observing over the past 3 weeks. All 6 endurance array surface moorings have dissolved oxygen sensors at 7 meters depth on the near surface instrument frame. 4 of the 6 surface moorings have dissolved oxygen sensors near the seabed on the multifunction node, or MFN. Both the NSIF and the MFN include other sensors providing additional measurements that place the DO observations within a larger context. These measurements include, among others, optical absorbance, attenuation, and backscatter, CDOM and chlorophyll fluorescence, temperature and salinity, current profiles, nitrate, pH, so PCO2 and pH. DO sensor data on the inshore moorings for both the NSIF and MFN and the Washington Shelf and offshore mooring MFNs is logged by a Seabird CCAT CTD. A subset is recorded once every 2 hours and telemetered to shore during the deployment. The full data record, sampled every 15 minutes, is available after mooring recovery. DO sensor data on the Oregon and Washington Shelf and offshore mooring NSIFs is logged by an OOI data logger every 15 minutes for 3 minutes at 1 hertz. The full record is telemetered to shore during the deployment. Telemetry rates are every 8 hours for the inshore moorings and every 2 hours for the others. Note, however, that the sampling and telemetry rates may be adjusted based upon conditions at sea. The primary issue impacting data quality is biofouling in the photic zone. As you can see in this example here, this photo shows the sensor face of the optode on a near surface instrument frame after a 6-month deployment. We have significantly mitigated the impacts of biofouling through the use of the AML UV biofouling control system, which was first introduced array-wide in spring of 2018. Data quality is assessed by comparing data from discrete samples collected during the deployment and recovery cruise and overlapping deployment data with the newer refurbished mooring and sensors deployed alongside the older active mooring. This figure shows the NSIF dissolved oxygen data from 3 consecutive deployments for the Washington Shelf surface mooring with the discrete sample data collected during the deployment and recovery cruises. These exploded views show data from overlapping deployments for deployments 9 and 10 and deployments 10 and 11 with the discrete sample data. Given the spatial and temporal variability we observe at the moorings, perfect agreement between the sensors and between the samples and the sensors is not really expected. Rather, we are expecting to observe kind of comparable values and trends as we are seeing here. Noted data quality issues are captured in an annotations database. The data is available online via the OOI data portal. There is a machine-to-machine API available to request data directly via scripts. We have developed Python, MATLAB, and R code to assist users, if desired, in downloading data from the M2M system. Data pulled from the M2M system is also available via the Global Ocean Acidification Observing Network Data Explorer, as well as the NANOS Visualization System Data Explorer. And for further assistance or information in accessing the data, you can see the oceanobservatories.org website, send an email to help@oceanobservatories.org, or sign up for one of the sessions tomorrow. What I'm showing here is a flow diagram of the available data products and associated processing steps to address some of the confusion out there about the surface mooring dissolved oxygen data and which data products to use. Included with the processing steps are data product names that are used elsewhere, notably in the Argo float program, in order to place the dissolved oxygen data from OOI into kind of a larger community context. The available data products are a function of how data from the sensor is logged, either the OOI data logger or the CTD. All the data sets contain the dissolved oxygen data reported in micromoles per liter computed on board the sensor. The data logger data sets include the calibrated phase and opto thermistor temperature from which dissolved oxygen reported in micromoles per liter is recomputed onshore using calibration coefficient stored in the asset management database system. For the data logger data sets, both formulations of dissolved oxygen concentration are present, and that provides an additional QC check since these values should be 1-to-1. Using data from either a co-located CTD or the CTD logger itself, the DO data is then corrected for the effects of pressure and salinity, and then converted to micromoles per kilogram. This final dissolved oxygen concentration data product is available in all OOI data sets. Here we're kind of presenting a regional scale event that we've been observing over the last 6 weeks. Here on the Oregon and Washington inshore and shelf sites, I'm showing the seawater temperature at the 1 meter, 7 meter, and near the seafloor, and the dissolved oxygen concentration at 7 meters and near the seafloor, as well as the northward wind velocities measured at the shelf sites. Missing data is noted with causes including storm damage during a large winter storm, a power system failure, and even COVID-19, where our normal mooring servicing cruise was delayed by 3 months and batteries were simply depleted. Of special note is a regional scale wind-driven downwelling and upwelling event that we've been observing over the last 3 weeks. With the onset of downwelling winds on August 16th, we can see increases in seawater temperature, as well as dissolved oxygen concentrations, especially near bottom dissolved oxygen concentrations. Measurements suggest that the inshore sites are well mixed, with bottom dissolved oxygen concentrations equaling those observed at the 7 meter site. The 4 sites all show comparable responses during this downwelling event. With the resumption of upwelling favorable winds, we start to see differences between the sites. Oregon shows colder water, well mixed to the surface with lower oxygen that propagates offshore over the shelf. The Washington sites, however, show the effects of weaker upwelling favorable winds. The inshore sites and shelf sites remain stratified, and the colder water doesn't really show up over the shelf. There's a lot of detail here, perhaps too much. The point is to demonstrate how these fixed time series data using a few measurements can be used to further our understanding of regional and local scale processes and how they tie into what's being observed right now with reports of dead crabs kind of washing up on the beach here in Newport. And so then in summary, we have collected 5+ years of dissolved oxygen measurements beginning in spring 2014. We've seen some significant improvements in the dissolved oxygen data quality within the photic zone with the introduction of the AML biofouling control system beginning in the spring of 2018. Use of shipboard discrete sample data and data from overlapping deployments assists in data quality assessments and improves our confidence in the accuracy of the measurements. Regional and local scale events can be identified, tracked, and analyzed. And with that, I'll wrap it up. Thanks.